The grinding is traditionally used to finish the parts whose geometries have been already created by another operation. Accordingly, the grinding machines have been developed to grind the plane flat surface, external and internal cylinders, and the contour shapes such as the threads. The most common shape is the surface grinder. The surface grinder usually used to grind a flat plane surfaces. It is performed using either the periphery of the grinding wheel or the flat face of the wheel. Because the work normally is going to be held in a horizontal orientation, peripheral grinding is performed by the rotating of the wheel about the horizontal axes, and face grinding is going to be performed by rotating of the wheel about the vertical axis. In either cases, the relative motion of the work part is going to be achieved by the reciprocating of the work past the wheel or by rotating it. These possible combinations of the wheel orientations and the work part motions provide the four types of the surface grinding machines. Cylindrical grinding is used for the rotational parts. These grinding operations divided into two basic types: external cylindrical grinding and the internal cylindrical grinding. In the external cylindrical grinding, is performed much like the turning operation. The grinding machine used for these operations closely resemble a lathe machine in which the tool post has been replaced by a high-speed motor to rotate the grinding wheel. The internal cylindrical grinding operates somewhat like the boring operation. The workpiece is usually held in a chuck and rotated to provide the surface speed of 20 to 60 meters per minute. The wheel surface speed, similar to the external cylindrical grinding, are used. The wheel is fed either into two-way, either as transverse feed or the flange feed. The centerless grinding is an alternative process for the grinding of the external and internal cylindrical surfaces. As its name suggests, the workpiece is not held between centers. This will result in a reduction in the work handling time, hence the centerless grinding is often used for the higher production work. A relatively new form of the grinding is the creep-feed grinding. Depth of the cut is 1,000 to 10,000 times greater than the conventional surface grinding. The feed rates are reduced by the same proportion. The material removal rate and the productivity are increased in the creep-feed grinding because of the wheel is continuously cutting, where in the conventional surface grinding, the wheel is engaged in the cutting for only a portion of the stroke length. The honing is an abrasive process performed by the set of the bonded abrasive sticks using a combination of the rotational and the oscillating motion. The common application is to finish the both of the internal combustion engines. The grid size range between 30 and 600, and the surface finishing of the 12 micrometers or even better. Usually is going to create a characteristic cross-hatched surfaces that retain lubrication. The lapping uses a fluid suspension of a very small abrasive particles between the workpiece and the lap. The lapping compounds is a fluid with abrasive general appearance of the chalky paste. A typical grid size between 300 to 600, and the main applications are for the optical lenses or the metallic bearing surfaces and the gauges. Superfinishing is similar to the honing. It uses a bonded abrasive strake pressed against the surface and reciprocating motion. Differences with the honing is shorter strokes, higher frequencies, and lower pressure between the tool and the surfaces. Usually is using a smaller grid sizes. To grind the internal cavities, a paste with a chalky abrasive material is compressed under the cavity, and in its way is going to add the abrasive action.